Hello everyone and welcome back. You're watching iCanCodeNow, and in this video we'll talk about this simple question that what is auto in C++? So auto is something that was introduced in C++11 and it is still available in C++20 and will be available in the future standards. And auto basically means automatically, obviously. So we will be using C++ basically, not we. C++ uses auto, AUTO word basically as a keyword. And what this basically does is that it automatically detects and assigns the data type to the variable with which it is used. So it is a compile time thing. It is detected by the compiler, and when auto is used, the compiler detects the data type of that variable by the from the value that is assigned to that variable. And since the compiler must declare internally implicitly uh, the data type of that variable using the value that is given to it, the variable must be initialized because if it is not initialized, the compiler won't be able to detect the data type of that variable. And auto keyword is not limited to declaring variables. These can be used to return data from functions or methods, and can be used as a return type. And one more advantage of using auto is that it makes the code more readable and obviously concise, because we can replace these longer syntaxes with simply auto. So let's go ahead and look at some examples that we have in C++. Here we can see traditionally we declare variables of different types. For example, int, float, double, character, boolean, and string data types are declared using these keywords. And using these keywords, the compiler knows that this variable is of this type, and this is of type double, and this is of type float, and so on. This is what we have been doing and what we normally do. But in C++11 and 11 onwards, so basically in modern C++, we can simply replace all these data types with auto. So as you can see that I have replaced all these data types with auto, and the compiler automatically detects from the value that is assigned to this variable that what type of data type this variable is. So this is required. A value must be assigned to the variable as soon as it is declared. So if a decimal number is provided, that the compiler detects that it is a double type, and if a decimal with a suffix f is provided, the compiler knows that it's a float type, and simply same goes for character, boolean, and strings. This is quite easy. We can usually we need data type when we are declaring a variable with its value, but now we can easily write this auto keyword, and the compiler does the job for us. We don't have to worry about declaring this data type correctly, and because this auto keyword does the job for us, and the compiler helps us automatically detects the type of that variable using the value that is assigned. And this works for all the data types, for example, long, short, and signed, unsigned, all the things. So the normal process of creating a variable with data type can be replaced with this auto keyword, and we can normally declare variables with using this auto keyword. So as we said earlier that this is not limited to declaring data types, declaring these simple data types. We can use this auto keyword in functions also. So this code here, as you can see on the screen, is a simple code with a small function in its own namespace, unnamed namespace. This is, by the way, recommended. And in the main, we declare this small C initial character type. This is automatically detected by the compiler, and this is a string type because it is a string assigned. So this is detected by the compiler that this is a string. This will be a string. Here we are going to call this method here, and this method returns simply the first character of that string that is provided as an argument. So we have declared this character return type, um, but since we know that this is the character data type that is returned, we can simply replace this character with auto, and everything will work the same. So this is basically the compiler automatically detects what kind of value is being returned by the function in the return statements. Also, if there are multiple return statements in this function, they all of these return types need to be of same data type, so the compiler detects the correct data type of that function to be returned. We can go one step ahead by declaring this argument of type auto. Now the compiler knows that here in this case string is being passed, so compiler will know at compile time while we are typing this, the compiler will know that this here is a string type. Since we are using indexes, the compiler knows that this is a string type. And since we are using returning a single character of that string, the compiler knows that this is a character type which needs to be returned. And since character is being returned, we can replace this character here with auto keyword too. So let me simplify this. So we have used auto here, and auto as a variable type. So this auto here is a character type, and it is from the return type of this function. So as you can see that using auto simplify the things that we do on the usual basis or normally day-to-day basis, like declaring data types or returning from functions or providing arguments and things like that. We can use auto to simplify logics and simplify the code. One other benefit of using auto is that, for example, let's look at this code. We have all overloaded this simple add method, and in this first method, add method, it is getting an int and returning a sum of ints. And in the second method, it is using floats and adding those floats. And in the third method, it is using doubles and adding those doubles. These three are overloads of the same methods, add. And when this is called, now which method will be called will depend on the argument types that are provided when this function is called. So in this first call here, the int method will be called, and in the second method, which is giving the value in 1.1f suffix f values, the float version of this overloaded method will be called, and in the simple decimal values, the double version of that overloaded method will be called. But since all these overloaded methods are doing the same job, adding these things, we can we can simply use this syntax. Instead of overloading the methods, we can simply replace the data types with auto keyword, and it does all the same. When add is called with 1 and 2, the argument types are of int, and these become int, and the return type is also int because it is adding integers. And similarly, when this is called, that these become float, and when 1.1 or 2.1 is provided as an argument, these auto keywords are replaced with double by the compiler. And same goes for the return type. The compiler detects the return type from the return statement. And we run this program, and we can see that the value of x is 3 and value of y is 3.2, which is a float, and value of z is 3.2, which is a double. But if we don't want the compiler to detect the return type of this of this method from the return statements, we can specify the return type like this in front of that method. So this works if the return type is auto. We can declare this return type here to tell the compiler that this is the expected return type and try to convert all the return statements into this type. So when this code is compiled, you can see that in the output we can see that all the values that are returned are 3. But since the first 3 is assigned to integer and the second 3 is assigned to float and third 3 is assigned to double, they are taking the memory that is occupied these data types. So integer takes 4 bytes, double take 4 bytes, and float take 4 bytes, and double take 8 bytes in 64-bit operating system. We can make this. We can test one more thing, that if we replace the return these data types with auto keyword, now this method is called with int arguments, and the compiler tries to return an integer because we have specified that try to return an integer in this method, and this returns an integer, and the integer is assigned to this x, which is an auto. Since integer is returned, the data type of x will be integer, and same goes for y, because this whole thing returns an integer, and y will be an integer because integer was returned, and same goes for z. And then if we compile this program, we see that all of these 3 xyz are taking 4 bytes of memory, which means that they're all integers. If we simply get rid of that return type that we specified for this auto keyword, the compiler will have to decide from the return statement that what the return type of this function should be. And if integer is passed, these two arguments will be integers, and the code will add two integers, and the resultant will be an integer, and the returning variable or value will be an integer. So the compiler knows that the return type of this method will be an integer in case of this first call. And when an integer is returned here, x will be assigned an integer, and based of that integer value, the compiler knows that the data type of x is integer. And in the second case, when two floating point values are passed, the compiler knows that the return type of this method now will be a floating point number, and the compiler assigns that floating point number to y, and based on that floating point number that is assigned to y, the compiler knows that the data type of y is a float. And same goes for double. The compiler knows that z is assigned a double value, and so the data type of this z will be a double value. And if we compile this program again, we see that this now is taking 4 bytes, meaning it is an integer. This is a floating point number and taking 4 bytes, meaning this is a float, and this is a floating point number taking 8 bytes, which is double. Auto keyword is not limited to these built-in data types. We can use auto keyword on user-defined data types like classes and structs. So here I have defined a simple class, and if we try to declare the object of that class, we can normally we do like this, and if we print this and these two these two variables, these two members of that class of that object, we get this value. But with auto keyword we can simplify this by replacing this human and star with this auto keyword. The compiler knows that since new human is being assigned, its type will be a human pointer, and the output remains the same as you can see. One more usage of using this auto is to simplify code. So whenever there are longer syntaxes of declaring variables, we can use auto to simplify the code. For example, in this code here, I've declared this vector type of which is storing all these first prime numbers, first 10 prime numbers. And in order to loop through these first 10 prime numbers, we can use this loop, or maybe you can use also this loop. But as you can see that we are trying to declare this using this syntax. We are trying to declare an iterator which iterates over this list. And in this for each loop, we are using this int n number to get all these numbers one by one and printing those numbers, as you can see in this output. Both the loops are printing the same thing, but we can simplify this by using auto keyword. So we can replace that iterator declaration with this auto keyword. The compiler knows that begin returns an iterator, so this is going to be an iterator type, and here we are using for each loop, so we are getting one number at a time. So the compiler knows that we're getting integers one at a time, so the compiler will know that this is an integer type. And if we compile that program, we get the same output as we have seen before. Also, we can use a auto keyword to simplify the declaration of pointers, and it's like we have declared this like we have declared this integer here, and I'm declaring this pointer to that integer. And if we print these lines, we can see that value of that is printed 30, and address of that is printed, and if we dereference that pointer, we get the value of 30 that the pointer is pointing to. But we can simplify this more by using this auto keyword, and the result is still the same, but we have replaced that that pointer syntax with this auto keyword, which simplifies the thing that it knows that we are trying to assign an address into this address of this some variable to this variable, and if address is being assigned to a variable, the data type of that variable needs to be a pointer. And what's the type of that pointer? It detects from the data type of the value whose address is being assigned. So if we print this, the output remains the same. So what auto does is simplify the things for us to declare using simple syntax or using simple this auto keyword. We can also use auto with the references. References are basically aliases. So if we declare a variable and we want to have an alias of that variable without copying that value, we can have an alias of that value. And to declare an alias, we use this operator here. And this basically creates an alias to this variable. And we can simplify this by using auto keyword here.